Hello. So picture this. You're a developer that's been working on a cool new feature for the past few months. You've just wrapped up the final piece, and you've run all your end-to-end tests, written thorough unit tests, and even addressed all the feedback from your coworkers. Your PR gets approved, and you merge it. Once everything looks really solid, you go ahead with the deployment. So as you're celebrating the completion of your new project, you suddenly get paged. But you're really confused because you feel like you followed all the best coding practices, so what could have possibly gone wrong? Upon investigation, it turns out that your worker that you just deployed introduced a breaking change. So hi, my name is Jing, and I'm a software engineer at Datadog that's working on tooling to ensure that situations like this can be avoided. As you're familiar with, when you're developing with Temporal, you are required to keep replay safety in mind throughout the development lifecycle. However, oftentimes at companies such as Datadog, it's difficult to do so due to the scale. So at Datadog, we actually have over 500 engineers that are constantly developing and iterating on over 150 workers. So this results in over 900 deployments every single day. You can probably imagine it's pretty difficult to manually check for replay safety alongside every single change you made and making business logic decisions. So this is why we've invested some time into building tooling to automate the detection of breaking changes. So let's start off with a quick recap of what exactly replays are and what replay safety is. So from the documentation, replays are when commands generated are checked against an existing event history. As you're probably already familiar with since you're here, temporal workflows allow you to write both long-running and durable business logic, and this can be useful for many cases. But at Datadog, we primarily use this for deployments, especially long-running deployments that may take multiple days. So temporal workflows allows us to track the progress of these deployments and continue rolling out application code changes even when we have system failures, such as when a node goes down or even just redeploying a new pod. Temporal is able to provide this durability through emitting events to the server every time your code does something, such as starting a new child workflow or activity. And using replays, it's able to continue making progress. So replays check these generated commands against existing workflow histories. So it kind of follows that replay safeties are when your code is compatible with old workflow histories that are already persisted in the server, and all of your code changes made must be backwards compatible. Any code change that is not backwards compatible is considered a breaking change. So what are some ways that we can actually introduce these breaking changes? As you're probably familiar, if your workflow is non-deterministic, which means that executions with the same input could result in a different output, that is a breaking change. If you're missing a version check when adding new logic that creates non-determinism, that is also a type of breaking change. Any incompatible removal of workflow activity types, workflow signals, workflow queries, and also workflow activity return values is also a way you can introduce a breaking change. Additionally, an incompatible addition of workflow activity arguments is another way to introduce a breaking change. And then finally, you can also have breaking changes at the wire level. And this is when your workflow activity signal or query payloads break the binary encoding. Unfortunately, we found that checking for all of these possible types of breaking changes brings up a lot of complexity for the developers, because this is pretty different from the typical bugs that you're used to encountering when you're not developing on Temporal. And this is why we wanted to reduce this burden for developers through building several tools geared towards breaking change detection. So let's go over tools that make up our solution. The 5 pieces are the static workflow checker, replay tests, local breaking change detection, deployment gates, and finally, temporal worker versioning. So each of these tools are slightly different and collectively address all of the types of breaking changes that we went over earlier. So let's kind of go over what exactly they do more in depth, and starting with the workflow checker. So our static workflow checker is a static analysis tool that runs when compiling Go workers. So this is sourced from upstream Temporal's workflow check with some minor deviations that we mostly made so that it's able to run within our build system. It runs by default on all of our workers at compile time in our source code. So the workflow checker is able to detect non-deterministic code changes through going through a set of predetermined non-deterministic functions. So for example, this would be functions such as calling time.now, or ranging over a map, or iterating over a channel. So next piece in our tooling is replay tests. And these are tests that users can define themselves, kind of like your unit tests, where you take a specific workflow execution from a live production or staging environment, and then you download a copy of it, so kind of like a snapshot of what you want the history to look like. And then these downloaded history snapshots are then replayed locally to check for breaking changes. So one major use case is that these tests can run in CI. So this automates some of the breaking change detection that you see. Additionally, these tests are really useful for local debugging because users can run these tests with test coverage or code coverage to assess which branches of code were actually hit. And you can also attach a debugger and set breakpoints to kind of further debug. Replay tests address the following types of breaking changes. So it's able to detect some non-deterministic workflow code changes that are non-version gated if the workflow history that you have downloaded is different. It also is able to detect incompatible additions of workflow activity arguments, and it's also able to detect all wire level breaking changes. So while this tool covers more types of breaking changes, the main limitations come from having to download and maintain local snapshots. So you'd only be able to detect breaking changes if your downloaded workflow history hits a path that's different from the code changes that you just made. And oftentimes, it doesn't really make sense to download hundreds, if not even thousands, of workflow histories by hand. Additionally, you'd also have to continuously maintain these snapshots as you make code changes. This is to ensure the accuracy of your tests and to avoid stale snapshots. So in order to address these gaps, we can kind of look to the next piece of our tooling, which is the local breaking change detection tool, also referred to as the local BCD tool. So this is a command line tool that developers can manually trigger to check for breaking changes. Similar to the replay test we discussed earlier, this tool also leverages workflow replays to replay code changes against workflow histories and detect breaking changes. However, the main difference is really the scale of replays here. So rather than having users download and maintain snapshots, the tool is able to query workflow executions by itself and then replay against all of these queried workflow histories. So this allows us to replay against sometimes thousands of histories at a time. It then will aggregate all of the replay failures that we just got back to detect breaking changes. So through using these replays, in addition with checking for the removal of workflows, activity signaling queries, this tool would be able to address all of the types of breaking changes that we went over earlier. So you can see that the types of breaking changes addressed by this tool is pretty exhaustive, which is a main advantage of using this, but this still places the burden on the developer to run it, which is one step added to the development cycle that we'd ideally like to remove if possible. Additionally, through running BCD early, this increases the chance of a race condition happening. So if we were to perform the check for breaking changes, but then a workflow with an uncommon code path is hit, your earlier check would not have had access to this workflow. So this results in a race condition and a false positive. So in order to reduce the time between actually validating for breaking changes and the actual deployment, we can look towards the breaking change detection deployment gates, which is the next piece in our tooling. So this gate essentially wraps the local BCD tool we went over earlier and allows us to run it before each deployment. It'll then manually prompt the user to review if the breaking changes detected are actually valid or will actually have any impact. And if it is, you can stop the deployment, but if not, you can also manually override if needed. Since this allows us to perform the check right before deployment, this minimizes the check that a race condition is hit. And similar to the local BCD tool, it also addresses the same types of breaking changes. And then finally, the last piece in our tooling is temporal worker versioning, which is slightly different from all of the other tooling we went over. Unlike everything else, temporal worker versioning works to mitigate breaking changes rather than detect breaking changes. So it does this through leveraging worker versioning. It allows workflow executions to be sticky to the task queue that the worker is specific to the task queue of a worker running a specific code revision. And this reduces the burden of needing to maintain version gates that adds a lot of tech debt. So I won't go into much more detail today, but if you're interested in learning more about this tool, you should definitely check out the Future of Friction-Free Workflow Upgrades, which is happening tomorrow at 10:40, which goes over this topic in a lot more depth. But now that we've gone over what each piece of our tooling kind of covers, let's look at it in the context of a typical development lifecycle. So as a developer writing workflows, I would start off by updating my code, and then once I'm ready to compile, the static workflow checker would kick in at compile time to check for breaking changes. As I'm iterating and testing, I'll also go ahead and add some replay tests so I'm able to check for breaking changes and have tests in CI. At this stage, I would also run local breaking change detection to check if my code introduced any breaking changes, and if it did, I'll probably need to add a version gate. Once I add my version gate, I can also use local BCD to check that my version gate is working the way I'm expecting it to, and there aren't any mistakes there. If there's any further debugging required, I can kind of go back and forth between using replay tests and local BCD here. So once everything looks good, I'd go ahead and open a PR, get that reviewed and merged. And finally, I'd go ahead with deploying. And right before deployment, BCD Deployment Gates would run to check for breaking changes. So if there aren't any breaking changes, deployment would continue as expected. And after my changes are deployed, temporal worker versioning will then be running to ensure that workflows are assigned to the worker running the correct code version and mitigate any panics. So for the purpose of today's talk, we're mostly going to be focusing on local breaking change detection and deployment gates. So the first part is local breaking change detection, which is a local CLI tool that developers can manually trigger to check for breaking changes. So here we can see a quick run of the local breaking change detection tool, and you can see some logs being emitted as the tool is being run. At the very end, you can see a success message because there are no breaking changes detected. So for developers using this tool, it supports faster iteration cycles through detecting breaking changes further left without ever requiring developers to actually deploy. Additionally, it also reduces the dependency on the developer's experience with Temporal. So especially for new users, you don't necessarily have to be familiar with all of the types of breaking changes. But this tool will just tell you if you have a breaking change, and then you can investigate further or even ask teammates for help if needed. So this sounds pretty good, but what does the process of detecting breaking changes actually look like? Let's go over the algorithm used to detect these breaking changes, starting with some definitions. So when discussing breaking changes, we're mostly going to be referring to two task queues, the source task queue and the replay task queue. So the source task queue is the task queue of the worker that we're actually sampling the workflows from. So we're going to be sampling for the heartbeat worker, listening on the heartbeat task queue, both open and close workflows from that task queue. Then we also have the replay task queue, which is the task queue that we execute replays on. And we need this because how we implement breaking change detection is through using a replay worker, and that requires a task queue to execute the replays. So for the actual algorithm, we start off by calling reflect, which is Datadog's internal interface exposed by every single worker. This interface allows us to query the list of workflows, activities, signals, and queries that are exposed on a given task queue. And since every worker exposes reflect, this gives us the ability to see which workflows, activity, et cetera, on any task queue. So in this step, we'd be calling reflection on both the source task queue and the replay task queue. So after calling reflect, we would get back those results and compare the workflows, activities, signals, and queries. And this allows us to determine if any were removed, which is a type of breaking change that we went over earlier. If there are any removals here, we'd be reporting these back alongside other breaking changes from replay failures, which is what we'll be looking at next. So to check for replay failures, we'll start off by sampling source task queue workflows that we plan to get the histories of. So in this step, we sample both open and closed workflows because we want to cover as many workflow code execution paths as possible, and open workflows cover paths that are currently being executed, while closed workflows cover recent workflow code that was hit but might not be currently running at the time of the check. So even though closed workflows might not be currently running, they still represent code paths that could be hit and might be hit again. So we do want to check for them as well. By default, we sample 1,000 open workflows evenly across time and 500 of the most recently closed workflows. So once that's done, we would go through the sample workflows and actually download the workflow execution histories. And then once we have it downloaded, we would actually replay the code changes on the replay task queue against the downloaded workflow histories. So the reason we want to replay is to determine if there are any replay errors, because these replay errors actually indicate breaking changes. So the final step is we would actually go ahead and collect and report the replay failures we got back to the user. In the report, we also have some additional features to help users better interpret the output. So for example, in the output of the CLI, we link the BCD run to a Datadog dashboard that aggregates the results, which you can see here. If you kind of look over it, you can see that this covers the types of workflows replayed against, as well as summarizes the successful replays and failed replays, and also provides some error log aggregation. So you kind of have a higher level overview of all the errors that you got back. And this is a really useful tool to start off with investigation just because it provides a better summary. So to summarize the entire process, we start off by calling reflect, and then we compare the workflow activities returned from reflect to check for that type of breaking change. And then we move on to detecting replay failures, starting off with sampling the source task queue for workflows, downloading these workflows' execution histories, and then replaying against these histories, and finally collecting and reporting the replay failures. So in addition to the default flow that we just went over, we also provide users with some options so that they're able to kind of tune the tool to their specific use case. The tool by default samples 1,000 open workflows evenly across time and 500 of the most recently closed workflows. But these numbers can be adjusted by the user, such as if they only care about all the open workflows running or closed workflows. Additionally, we also have an option to fail fast and return on the first replay error detected. And this is from feedback from developers that want a faster iteration cycle, especially when they only want to know if they introduce a breaking change, but not necessarily get a summary of every single breaking change that their code has. And then finally, we also have the option to filter source task queue errors. And this is just because oftentimes error in the source task queue are errors that have already been merged into main, which is why they're present on the source task queue. And because of this, this isn't indicative of any new breaking changes that the code is introducing. So we're giving users a way to filter them out. So while the local BCD tool is a good starting point to make breaking change detection easier, this tool still places the burden on the developer and leaves time between checking and deployment, which allows potential race conditions. So this kind of brings us to the BCD Deployment Gate, the next piece in our tooling. So in order to automate BCD, we use a pre-upgrade hook provided by our deployment system to run automations before rolling out a new version. And this allows us to just verify that breaking change detection passes before every single deployment. So if you remember from earlier, local BCD requires both the source task queue and a replay task queue. So while we have the source task queue for every single worker, we need a replay task queue. And this brings us to why we create an ephemeral task queue at the next code version, and then we take this and use it as our replay task queue in our BCD workflow. So this allows us to check for breaking changes between versions. To enable the gate, we would simply toggle on the enabled value to true, and then the gates will automatically start running before each deployment. After turning on the gates, I can then trigger a deployment as a user, which kicks off BCD running automatically. And if BCD did not detect any breaking changes, we would deploy as normal. Otherwise, we would send a manual judgment prompt to the user to, through Slack and our internal deployments UI, so that they can manually check if they want to override or if the changes are safe. So this prompt would look something like this. And if I received this prompt, I would probably want to investigate a bit more. So I would head over to the Deployment Gate dashboard linked to see what breaking changes were detected. So if we look at this dashboard screenshot here, we can see that only one workflow replay actually succeeded, which kind of indicates to me that if I were to proceed with this deployment, there would probably be panicking workflows. So I would actually go back to the prompt and respond with stop deployment. And this would bring us back to the flow, which stops the deployment. But in another scenario, if I determine that these changes are safe to proceed with, I could respond with ignore breaking changes and continue deployment, and my worker would continue deploying as normal. So while we've reduced the burden of detecting breaking changes from developers, there's still some known limitations of the tool. So we can still miss uncommon code paths because even though we try to sample as many workflows as possible, it's impossible to guarantee that every single possible code path is sampled and will be hit in an open or recently closed workflow. Additionally, the breaking change detection algorithm is also difficult to optimize because we want to avoid overloading servers. So this requires us to go through a couple of replays a time at most. It's also expensive to run because we sample many workflow histories, and a lot of these are not recently accessed. So this results in cache misses and forces us to actually go and access our database. And then finally, there's a gap in debugging and responding to the output because the ease of investigation heavily depends on the replay failure messages, since they're the main source of information on where the breaking change is. So for example, you can see here a list of all the replay failure messages we got aggregated over the course of a month. As you can see, most of these error messages specify the event ID or the child workflow ID, but oftentimes there's a lot of logic introduced between events that makes it difficult to determine where the breaking change is. In fact, the second most common error pattern, as you can see here, was actually the only clue we had to go off of during a replay safety-related incident last year. So if we look at this, it says that breaking changes were detected, there's an unknown command type, and it provides the child workflow ID, and then goes on to say possible causes are non-deterministic workflow definition code or incompatible change in the workflow definition. So that's a lot of words that I don't fully understand what it means, and judging from your reaction, I'm not sure you do either, or perhaps you're smarter and you actually know what's going on. But my point is, the messaging can be pretty unclear, even for people who are experienced with Temporal. And for users that don't really have a background with Temporal, it can oftentimes be even more confusing. So you can probably imagine during the incident at the end of last year, it was really difficult to determine where exactly the error was happening simply from reading this message. But all of our deployments were locked up, and there were panicking workflows, so we had to resolve the incident as fast as possible. Eventually, we were able to figure out that all of the workflow IDs all corresponded to one type of workflow. And through using logging in replay tests, we're able to figure out exactly which line the error actually occurred. So while we were able to eventually figure it out, if we had structured replay failure messages, it would drastically reduce the time it took to recover. For example, if we look at this error a bit more closely, rather than providing the child workflow ID, if we were able to have the first event ID of the replay failure, it would be a lot more useful since users wouldn't have to figure out which workflow IDs correspond to which workflows, and they would also know where the replay failures actually started to happen. If possible, it'd be even more valuable to provide information as granular as the specific line number causing the replay failure. So something like this. And then additionally, we also saw earlier how the phrasing was a bit confusing, so we can rephrase it to be friendlier for those that aren't as familiar with Temporal. Something like, you likely modified a workflow definition. So this is a bit clearer and kind of gives you actionable steps on where to start investigating and what you probably did wrong. So from this, we can kind of see the improved log would look something like this. And compared to the original error message, I think it's a bit clearer and a bit more concise as well. So while having log aggregation in our dashboard does help summarize and provides an overall view to help start with investigation, changes like this help us provide more actionable feedback to our users, which translates to less replay safety-related incidents, or at the very least, faster remediation. So after everything covered today, what were our main learnings, and how can some of these be helpful for you to hopefully take away? We found that automating workflow replays to detect breaking changes has been really effective in getting users to discover breaking changes earlier on. And we've also noticed more questions around actually debugging breaking changes and less replay-related incidents, which potentially suggests that our tooling has helped. Since the majority of this actually relies on upstream temporal replays, and we've done very minimal work to change it up, this is actually available to all of you, so it should be pretty straightforward to implement regardless of your stack. We also believe that checking for breaking changes during deployments or as close to deployments as possible improves the accuracy of results since it minimizes the time between the check and the deployment. And this reduces the chance of an open workflow with an uncommon code path being spun up and causing a race condition. Having supporting investigation tools has also been crucial, especially during incidents. So we've noticed that using replay tests with logging is super helpful for granular local debugging. And we also have our BCD dashboard, which offers a better high-level overview to have visibility and aggregation that simply relying on replay failure messages can't provide alone. And then finally, as we just went over, investing efforts into improving the replay failure messages going forward will help make all of our tooling more actionable for our users. But one thing I do want to say is even if you don't take away anything else from today, there's one thing that you should definitely do, and that would be enabling static check. This was purely sourced from upstream temporal, so you can enable this really easily for your own systems. I've linked the repository for static check in upstream temporal, as well as other helpful resources on workflow versioning and replays if you want to dig a bit deeper on your own time. But that's all I had for today. I left the QR code up in the bottom corner if you need a bit more time. If there are any questions, I'd be happy to take them now.
We've got time, excuse me, for one question, and whoever raises the hand first. All right.
Hi there. Is this on? Oh, so you said that you're having difficulty covering uncommon code paths, for instance. So have you guys been able to correlate anything like maybe a workflow definition with high cyclomatic complexity maybe causes an increased probability of panicked workflows in production, and being able to use that to sort of inform your developers on how they might refactor their workflow definitions to reduce those kinds of concerns?
Sorry, can you repeat the second part of that?
Yeah, so using maybe static code analysis or sort of some correlations between the complexity of your code and the rate of panicking workflows and so forth to maybe indicate to your developers that it's an opportunity to sort of refactor the way that they build their workflows and maybe provide insights into how to better build their workflows
right.
to reduce the complexities and so forth?
That's definitely an interesting idea. So how we've kind of thought about this is that because users are constantly changing their code, while we could predict things like that, it's difficult to actually guarantee that our recommendations are effective. And additionally, we can't really predict the future, so it's really hard to assess what code path would be hit, especially if there are external dependencies in the code that wouldn't be as simple as simply running a static check or kind of having a model to guess the complexity correlating to breaking changes, which is why we use actual existing histories rather than trying to predict. But that is an interesting idea, and I'd be happy to chat more about it afterwards.